Hi everyone, good morning, good afternoon, or good night. My name is Eduardo Camargo, and today we're going to talk about a very hot topic, AI assisted software development. So, this next session will walk us through generating all the source code for an example REST service. Our speaker for today, Sashir, one of our principal engineers, will be leading us through this Open API workshop and giving recommendations and best practices as we go along. But before we jump into the session, a very quick reminder to follow us on social media and check out sessions of our Global Dev Week. Use the chat to leave your comments and questions. And without further ado, take it away, Peter.
Thank you, Eduardo. Let's start the session. AI assisted software development. Okay, what are we going to present here? It's about develop software with the help of AI. How are we going to present it? Well, through the solution of a case study. What are we going to use? OpenAI technology to generate code. That's our session. Okay, agenda. The first is the context about the AI technologies. The second point is talk about large language models. Then we present the case study. Uh, Next, we are presenting the solution for that case study using an AI-assisted approach. Finally, the key takeaways. The context. Okay, what is AI-assisted software development? Is to develop software with the help, with the support of the AI models, models that have been trained, have been learned a lot of code from different sources. For example, GitHub code. So in that way, you can increase your productivity. The underlying AI technologies, AI is a very big area, but the areas specific to our problem is the machine learning, the natural language processing, and the deep learning. Deep learning is a subset of the previous one that uses artificial neural networks to model and solve complex problems. Okay. Uh, a key topic is the transformer model. Transformer model is a, a model created by Google in the 2017, presented in the Attention is All You Need paper. It's important because it enables parallelized computation, leading to significant advance in the language understanding and generation models. Okay. Now, let's talk about large language models. Well, those are AI systems that can understand and generate human-like text, often based on deep learning techniques. These models are trained on extensive data sets consisting of text from diverse sources like internet, Wikipedia, GitHub, code base, for example. Uh, these models can understand and comprehend complex queries, simulating the human-like conversations, and generate appropriate text. Related terms to LLM are generative AI. Generative AI is a term used when you put emphasis in the context creation function of the LLMs. As well, we have the foundation model. For example, we have an LLM like GPT. GPT is the foundation model for specific products, for example, for ChatGPT. Okay, we have main models in those days. We have GP3 from OpenAI. We have the version 3, 3.5, 4. We have from the Google side, we have BERT, Lambda, Pond. We have Llama from Meta. We have Chinchilla from DeepMind and Bloom for Hugging Face. Prompt engineering is the practice of designing and optimizing instructions. Instructions are the prompts. giving to a language model to gather desired responses or completions. Um, in the image, you can see the the input is entered by prompts. Prompts are the input for the AI models. AI models interpret those input and generate an output, the completions. Okay, that output could be a huge text, or it could be code also. So prompt engineering involves crafting a specific input tests or queries to guide the model's behavior and generate accurate and relevant outputs. This involves, for example, giving high-level task description, provided context to the model, specifying the desired format that you want to be exposed by the model, or just example to guide the model, the AI model. Okay, let's review a prominent LLM. Is the OpenAI GPT. GPT is an LLM model developed by OpenAI. Okay, it is a powerful language model that generates human-like text based on input and receives. Its prominent specific product from GPT is the ChatGPT, ChatGPT product. Okay, the latest version of GPT is 3.5 and the version 4. But GPT exposed its functionality via an API. By the API, it provides a way to interact programmatically with GPT models. So in that way, the developers can make API requests to generate text and receive response, and in that way, integrate it into their applications and products. The latest version, the latest model of the GPT 3.5 family is the GPT 3.5 Turbo. This is the latest version, which can understand and generate natural language as well as code. Okay, that is our context. Now, let's talk about the case study that we want to solve. Okay, we are talking about a tracking expenses system. We want to create the backend part this backend of this system. Big requirements at big level are we can create users who will be recording expenses. We can create projects where the users will be recording expenses for. An expense will be recorded with a user, a project, a date, and expense type. We can query, modify, and delete users, project, or even expenses. Those are the requirements for this simplified system. Okay, we are providing a solution technical design for this case study. In the architecture side, we have a REST API application with the typical layers like a controller, layer, service layer, the repository, and the model layer. All of them based on the relational database. We are using as a framework, we are using Spring Boot 2.7, and the database is MySQL. In the image, you can see also the four entities involved in this solution. We have expenses. Every expense has a product and user and expense type. Projects and users can have many expenses as well as expense type. Okay, now let's review the specific solution that we are providing for this case study using AI approaches. Okay, to provide a solution, we are going to use the OpenAI API to generate code. This API has a request. In that request, we have the URL and the endpoint, the chat completion endpoint. Also, we have different parameters, but previously you need to provide an authorization using an API key. The API key, you could get that from your OpenAI account. Okay. The parameters, we have the model, is the first one. In the model, you can specify what specific model you are going to use for making requests to the API. In this example, we are using the latest one, GPT 3.5 Turbo 16x. 16x means a model that handles 16,000 tokens. Okay, a token is approximately 3 or 4 characters. Okay, the next parameter is max token. Max token is a number that you specify in order to limit how many tokens are you going to interchange in this request. It's recommended to use the 50% of the maximum limit of the model. In this case, 8,000 tokens. Temperature is another parameter. This parameter is useful if you want to make the solutions more deterministic or less deterministic. 0 is more deterministic. Okay. String is the for parameter. String true means that you could receive the responses token by token. String false, the service, the API is blocking until they have the complete response and then answer the full code. Okay. We have also the messages. The messages parameter is an array of inputs. Every input have 2 attributes: the role, that could be system, user, or assistant, and the content. In the content, you specify the prompt, the indications that you are providing to the model in order to receive a specific code in this case. In the system, you are indicating, you are prompting the model uh, uh, big indications like what personality is going to assume the model. In the user content, you provide a specific requirement to generate code. Okay? Well, the response have many attributes, but the main one is the choices message content. Okay, in the content you are going to receive the specific code. Okay, in this case we were asking the model to generate a Python function to get the max of 2 numbers. Okay, here we have the Python function. Another important parameter in the response size is the total token. In that parameter, we can know how many tokens has been interchanged in this interaction with the OpenAI API. Okay, now let's talk about the prompt-driven development. So, if we are going to develop software using AI or based on AI, we need to change the way that we specify the solution. We are not going to use code. We are going to use prompts, okay, in order to specify what we want to do from the model. So, in order to do that, we are going to specify some steps. The first one is identify components. We need to identify components, for example, could be the high-level components or the different programming languages. For example, in the right side, we can see that we have identified 2 components: the SQL component for the database and the Java component for the backend Spring Boot part. Okay. The second step in this process to guided by the prompts or driven by prompts, we have the set system behavior. We need to set the context per each component, such as what tech stack are going to use, or indications, for example, to don't display the code, because by default the models are going to explain the code, provide the code and explain the code. But maybe for in this situation, we don't want explanations. Okay, this is the system part of the API. Here we have, for example, for the SQL part, we are prompting the model to, for example, you are a very experienced developer in MySQL. We are setting the personality of the model. Please don't explain the code, just generate it. Specific indications. General indication for the model. because the specific is in another part. For the Java, something similar. For example, you are a very experienced developer in Java and Spring Boot. Okay, we are setting the tech stack and the personality for the model. Don't display the code, just generate it. Okay. Also, some indication specific for the Java language. For example, the pattern for the file names, the pattern for the packages. Okay. Now, the third step in this process to prompt-driven development, we have the provide coding request. Now, in this step, we are going to provide the specific requirements to generate code. This is the user part of the API. In this part, you will define the set of prompts per component. Prompts are entered in comment blocks according to the language. You can see in the right side, for example, the prompt for the user SQL part. This this prompt is entered in a comment block. In SQL, the comment blocks are slash and asterisk characters. You can see here in the beginning and in the end. Another topic is the language must be indicated at the beginning of the prompt. Yeah, here we have MySQL is the language that we are setting for this prompt. The other indication is structure the prompts in numbered subtasks to be placed in other lines. Yeah, in this case we are specifying three steps. The first one is generate the DDL scripts to create the tables and foreign keys, and we are specifying the 4 tables with the number of the table, the fields, number of the field, and the type, and even in some cases the size of the type. The second step in second subtask in this prompt is to generate the DML script to fill out with fake data. The model could understand that indication. Use realistic values. The third one is generate 4 expenses with random combination of users, projects, and expenses types. Those are the way that we are indicating to the model how we need to generate the code. Okay, you don't need to enter SQL language or code just at the level of the prompts. Okay, so here we have the prompt for the user part. We are splitting the user part in two. And the first one, we are setting the language, Java 11 and Spring Boot. Subtask, the first one to generate the model classes, the repository for the second, global exception handler for the third one, service for the fourth step, REST controller for the last one. We are setting our expectations in a structured way. In the second part, we are asking the model to generate the unique test classes for all the service and REST controller classes, not for all code, just for service and REST controller. Testing happy, as well as an alternative and error patch. And using mocks where appropriated. Make sure to catch exceptions thrown by the tested methods. Well, you could be as specific as you want in order to generate the expected code. Okay, best practices for user prompts. AI cannot read your mind, so you need to provide clear instructions, clear prompts. It's important to take into account the one word more or one word less in the prompt can make a big difference. So you need to prepare your inputs carefully. Try to rephrase the prompts until you get what you expect. You need to try many times in order to get what you expect. Order the prompts based on the dependencies between the parts of the code. Yeah, you need to structure this in order to follow a sequence, a logic sequence. Review carefully the generated code to assure its quality. It's important, this part. When you don't trust in the code, in the generated code by AI. You need to review, you need to test. If a request plus response tokens exceed the AI limits, then split up the prompts and do so many execution. That was our case because, as you can see, we we needed to split our prompts for the Java part in two parts. Okay, because if that was in only one request, the responses could be so huge. So maybe the limit of tokens could be exceeded. Okay, the last one is the AI is unaware of previous execution. AI don't know about the previous execution. So you need to provide it with the proper context on each execution to get valid results. Okay, you can use, for example, if you are going to you require many executions to get the code that you expect, you could use the response from the previous execution as a input, as a context for the next execution. Okay. Now let's review a demo about how we are generating code using AI tools. Okay, here we have the page of OpenAI uh, with the endpoint from the AI, the API. We can see the URL, the request, specification, the response in order to use this API. Okay, in our project, we are automating the generation of code via a bash shell script in order to make the calls. We have the default value for the different parameters. We have the different prompts in different files. We are orchestrating all those files in a JSON structure that we have created. It's a custom structure that we have created to generate all the code. We are calling the batch shell using that orchestrator. So we are generating the code. You can see in the left side, we have the SQL part, for example. All the code has been generated, and we are going to execute that scripts in a database. Now the scripts have generated the tables and also populated all the tables with the data that we are indicated in the prompts. Yeah, even for the expense, we are generating 40 expenses. Also in the Java part, we are generated all the classes for model, repository, service, controller, and even for the unit test, because we are specified that part. The code has generated taking account the relationships between the entities. Okay, all this code we are going to use in a Spring Boot project that we are set it previously. In this Spring Boot project, we are set it to use Maven. Also, we are created a shell script, another shell script, in order to split up all the files that you have seen how has been created by the AI. All the file has been created in only one file. So we need to split that in order to put those files in specific folders and specific files. So this project is a Spring framework with Java 11, with the dependencies for web data, Lombok tests. We have the database using a connection for that database that we have set it. And now we are going to run the shell script in order to split all the files. Yeah, you can see the structure has been created and populated with all the files with the content generated by the AI previously. Yeah, we are refreshing the project just to be sure that all the classes are in place. Yeah, even for the test classes. Okay, now we are exercising every unit test in order to verify that everything is in place. Yeah, Spring Boot is running the test. Yeah, all the tests are running. You can see finally test run 40 executed successfully. Okay, now we are going to execute the, the Spring Boot project in order to expose the APIs for handling this tracking expenses system. Okay, yeah, the Spring Boot is starting. Finally, the starting has completed. So we, in the Postman project, we can see the user's endpoint. Yeah, is responding also for the project's endpoint for all the projects. The same for all the expenses. Yeah, for expenses. Also, we can see the specific expense. Yeah, created a new expense using the endpoint, using the post endpoint. Yeah, the expense has been created, the 41 expense. Yeah, we have this is the new expense. The name is David Taylor. Now we are going to modify that expense. Yeah. Now that expense now have a different description and a different user. Yeah. Uh, Hitting the get all, we have the 41 expenses. Now exercising the delete endpoint. Now we have only 40 expenses because delete has been executed. Yeah, we have all the log in the Spring Boot project that has been showing that the endpoint has been executed successfully. Okay, this is an overview of the solution. Now let's talk about the key takeaways. Okay, the first one is gain productivity. Yeah, AI, it's important because if you can use in a smart way, your productivity could be increased. So you can focus on more important parts of the project because the AI could generate the boilerplate of your project, the repetitive part of the project. So you don't need to focus on that. You could focus on the most complicated parts. So you gain productivity in this way. The second one is verify results. It's important always verify the result of the generated code from the AI. Okay, you must not trust in that generated code because that code could bring with some security risks, with some bad practices or code smells. You need to review that. You need to be sure that the code is generated with the best quality. Okay, so you need to make code review, a lot of code review. The third key takeaway is the stay updated. It's important to you to be updated in all the things related to the AI technology because uh, month by month or even week by week, we have updates, upgrades in the models. We have the models with better functionalities. So you need to stay updated in order to use the best approaches, the improved approaches in order to use in your software development project. Okay, so that's all. Let's go with you, Eduardo.
All right, thank you, Sashir. This is great. I never get tired of just seeing how much AI can contribute to software development. So thank you so much for the session, and I hope everyone enjoyed the session as much as I did. Uh, Folks, be sure to leave your comments and questions for Sashir on the chat. And thank you all once again for this great session. Be sure to review our Devweek agenda on our official website, and see you on the next one.